Welcome all to this lecture series on ESP32. I am vApplicationIdleHook working at Entity, Intelligent Devices and Smart Solutions. This is fourth lecture of Module 2 FreeRTOS and ESP32. In this lecture we will see idle task and idle task hook. The tasks we created using the task entry function that had vtask delay or vtask delay until went to the blocked state. While these tasks were in the blocked state, they are not able to run. So they cannot be selected by the scheduler. But there must always be at least one task that can enter the running state. To ensure this, the scheduler automatically creates an idle task for each core when scheduler is started. Let us see where this idle task is created in the task.c. So in ESP folder in home directory, ESP directory, open the version we are working on in ESP-IDF, components, FreeRTOS, FreeRTOS kernel, then tasks.c. So in this, we'll search for trv create idle task. This is the function that creates the idle task when scheduler is started. We'll search for this. So it is called from vtask start scheduler. So when scheduler is started, trv create idle task, create idle tasks for each core. The idle task has the lowest priority, priority 0. To ensure it never prevents a higher priority application task from entering the running state. However, an application designer can create tasks with 0 priority, thus preventing the idle task from consuming processing time that could be used for doing something else. But it is not a good idea because if we are using vtask delete to delete a task for itself, then in such cases, the idle task is responsible for cleaning the kernel resources used by the task that killed itself. So, there are the chances of memory starvation if the number of such tasks are large. So, FreeRTOS has provided idle task hook function to add application-specific functionality directly into the idle task. While writing an idle hook function, care must be taken such that the idle task hook function never attempts to block itself or suspend itself, as suspending the function will suspend the idle task. So now let us see how idle hook functions are created. Let us open Visual Studio Code. Open the directory we were working on. We will create new main file for idle task and name it suitably. Here let us include the header files as include stdio.h, as include FreeRTOS directory, FreeRTOS.h, then include FreeRTOS directory task.h. So now in this demo we will make idle hook function, and in that function we will increment a global counter, and when the counter is a multiple of 100 we will print it. In another task, we will just print the counter at that time and block the task. So let us start. We will make idle hook function. The signature of idle hook function is void vApplicationIdleHook idle we will make a global counter. Volatile, so that the compiler do not optimize it out. UInt32P. UL counter, initialize it with 0. We need to include int type.h. int type.h. In the idle hook, we will increment the counter. And print at the 100th multiple. If remainder with 100 is equal to 0, then print the counter value. UL counter. Now make a task entry function. Void v task function. It takes void pointer parameter. In this task entry function, we will just print the task name with the counter value. So to catch the parameter, we make a character pointer. PC task name, we will cast the void pointer to char pointer. Then infinite loop for the task. We will print the task name and the counter value. PC task name, then counter value. Then we will delay the task for 250 milliseconds. This will convert, TDMS to tick will convert 250 milliseconds to number of ticks. Now we will make the app main function. Void app main. Then we will create the task. Pinned it to core. Task entry function. Stack depth 4 kilobytes. Then argument to pass to the task entry function. From task 1. Priority 1. Then we won't have any handler running on core 1. Now we will build it. We have got some typos. Here by mistake it is same character, actually it's a B. This pointer, white pointer, the argument that is coming to this function, will build it. We'll build it. We'll flash it. Flash was successful. We'll monitor it. So as you can see from task 1, the counter is always 0. So let us examine this. We'll put one new line here. Build it. Flash it. Monitor it. We can see from task 1 the counter is always 0. Why this is happening? Because even though the task is going in the blocked state, the idle hook is not being called. This is because we have not configured it in the menu config. It is not there in our SDK config. So we will configure it in the menu config so that our SDK config knows that we are trying to use idle hook. So let us do that. Break the program by pressing Ctrl plus closing the square bracket. Now type idf.py menuconfig. Enter. In the component config, FreeRTOS, kernel, config use idle hook. In idle hook, we'll press space such that it is selected. Space will select the idle hook. So now press escape again and again press escape, again press escape and press Y to save the configuration. Now we will build it again. We'll flash it. And then monitor it. So let us break the program by pressing Ctrl and closing the square bracket. Now we can see that the counter is incrementing. We are not calling this function anywhere in our task. So who is incrementing this counter? Whenever the task goes in the blocked state, the idle task starts running and the idle task calls this vApplicationIdleHook and increments. Thus, we can see these are the print values from our user task and this from the application. Every 100 it is printing. So the application developer can use this idle hook to do the housekeeping or the other and non-important tasks that he wants to run when CPU is in idle state. Instead of wasting time in idle task, the user can do the non-important or housekeeping work. So that's all from this lecture. See you in the next lecture. Thank you.